So good morning everyone, and welcome to WEM. It's good to be back after 4 years. Been far too long not seeing everyone. I certainly recognise some of the faces in the audience today. You, Mr. Swain. You too, John. This is Flow Forum. I think Flow has been, to say it's been manic over the past couple of years is somewhat of an underestimate. UMON 3 drivers, UMON 4 drivers, and what was really scary is somebody said to me yesterday, it's only going to get worse. Today is basically to see how bad it's going to get, how busy that we're all going to get in the future. Tomorrow the Pollution Forum is just going to add another level on top. It's going to be an interesting next 10 years, I think. So without further ado, I'm going to introduce our first speaker, Rob Whittaker from the Environment Agency, who's going to give us a bit of a Regulators update and tell us what we've got lying ahead. Are you going to talk about UMON 6, Rob? The very fresh driver? Maybe. If not, I'll be mentioning it. I'm going to introduce another couple of theatres. So I'm going to leave you in Rob's capable hands for about 15 minutes, 20 minutes, and then I'm going to come back, and then I'm actually going to deliver the second speech because we had a last-minute dropout. So I'll leave you in Rob's careful hands and enjoy.
Thanks, Oliver. Not sure about capable hands, but you're in my hands. Okay, this is essentially an update on where we've got with delivering UWEM, the flow to full treatment monitoring, the spill to environment, spill to the storm tank, everything really around sewage treatment works. So I hope you're in the right place. It's not air quality, I don't know anything about that. So I'm Rob Whittaker, I work in the regulatory development team. We concentrate on trying to improve regulation of things which are perhaps overlooked and change the way regulation is delivered so that it suits everybody concerned, really, including, of course, the public. So, permitting from wastewater treatment works, what do we include? Well, we include quality limits, and we include flow to full treatment limits, which limit the amount of flow that can be treated. We include dry weather flow limits, which in turn govern the amount of flow that discharges on a day-to-day basis. For 20 odd years, we've had really good compliance with final effluent quality limits. That's been used as a metric by Ofwat and the EA under the EPA and ODIs, and it's been very well complied with, and that was really the only measure of sewage treatment works. So we knew there was issues with flow to full treatment not being complied with, and that was a trade-off with the dry weather flow limit, which the dry weather flow limit again was probably about 6 to 8% of sites on an annual basis were not complying. They were exceeding their dry weather flow. The dry weather flows had been rebased to a compliant situation over 10 years ago, so that 6 to 8% was rising, and again we weren't quite sure that the conditions in the permits were doing the job. So come AMP6, back in, gosh, seems a long while ago now, in 2015 to 2020, we had a driver for that period which included to 270 monitors on the flow to full treatment, but unfortunately we didn't get MCERTS applied to it. We also had a massive programme of EDM on not just sewage works, storm overflows, but on network overflows. And again, that being a fairly new and rapidly introduced driver and having certain restrictions on how the cost of that driver that was given to us by government, again, didn't have MCERTS. And of course, you probably know now there's been issues with both of those programs. The FFT monitoring we put in, whilst we required an accuracy and uncertainty of plus or minus 8%, in reality that was difficult to get without that being part of the funded driver. So some sites didn't meet that. And so it was really a tester. We were trying to justify the need for monitoring because there's a little bit of a chicken and egg going on there without having the evidence of compliance issues. It was not easy to justify to government or through the companies the need for further monitoring. So the aims of the PR19 program, which coming into effect from 2020, was to improve that regulation for both dry weather flow compliance and for FFT, improve data quality, which had been somewhat lacking, and develop conditions which were more enforceable and more protective of the environment. So effluent we measure as a total daily volume when we're measuring the effluent flow, the day-to-day flow, and that's MCERTS certified. The current dry weather flow condition, which is the one that governs the day-to-day flow, was improved over 10 years ago and was very much a cooperative driver where we expected the companies under our guidance to manage their FFT, stay compliant with it. But as we say, because it wasn't a very protective condition, it wasn't a pass-fail, it tended to get overlooked, and there's been a history of non-compliance. The total daily volume is measured as an 80%, a flow that's exceeded on 8% of the days, and it's assessed for compliance against a smaller flow that's exceeded on 90% of the days. And guidance simply requires DWF to be exceeded. Not to be exceeded, should I say. So if a dry weather flow is exceeded, it prompts an investigation. That investigation is to find out the cause, whether it simply needs an uplift in the applied for dry weather flow and appropriate tightening of quality limits and potentially pass forward flow and storage. But if the investigation found that there was just heavy rainfall throughout the year, so there was no real dry weather flow to be measured, then that was a reason to wait another year to find out if the dry weather flow was repeatedly exceeded. If they couldn't find a cause, and this was frequent, then there was no prompt to do anything about it if they couldn't find a cause for the exceedance, and again it just went on to another year. And consequently many sites were left non-compliant for prolonged periods until we got to the point where we started failing some for not having sufficient response to exceedances. But that clearly wasn't an appropriate approach. Sorry, I lost my So to improve permitting, what we did was retain the dry weather flow limit, but we had new conditions which are added to it, which only allow 2 exceedances in a 5-year period. If there's a third exceedance, then that becomes an absolute fail. So that became now, or will become, a clear kind of unambiguous pass-fail outcome. This kind of aligns with EA guidance, which was always to prevent dry weather flow exceedances, and it facilitates growth because there's no hold-ups when we're approached for growth. It can take quite some time to get through all the consultation to agree the final effluent limits. So people applying for it after they've already exceeded it was, and still does, cause problems with planning. The first assessment will be in 2026. We've already issued the permits for dry weather flow, which were at risk of exceedance, and because they have to look back, first pass fail will be in 2026. So why do we monitor FFT then? We've captured the quality and we've captured the volume, and together those give you the polluting load that's being discharged. Well, the FFT, of course, is governing the spill frequency, governing how much spills untreated from storm tanks at sewage works. It's a fairly sensitive setting because it's quite low. It's usually less than 3 times the dry weather flow average. So on a peak, it can quite easily spill if the setting's too low. And there were pollution incidents caused by settings being too low. There were WFT failures that were unexplained without any evidence of where the pollution was coming from. And site inspections started to reveal issues with FFT compliance. Subsequently, during AMP6, there were high-profile pollution incidents and prosecutions, and that prompted increased interest from public, media, and the calls for this compliance aspect to be very clearly transparent. So by putting the FFT monitoring on, we can allow compliance to be universally compared as well. Without that monitoring, there was no way of comparing companies and giving them the incentive to perform well or to be shown if they're not performing so good. And also it gives us the ability to better understand water quality impacts if we know what's being discharged and how often and how much at sewage works. And we found also storm tanks were being misused. They weren't being emptied quickly enough, and that again is usually a symptom of either maintenance or the insufficient FFT setting not allowing time during low flow periods to empty the tanks, and that was causing problems. So FFT monitoring. So it wants to move. Seems to have frozen. Oh, thank you. It's gone too far now. Yeah, I lost the prompt on the screen. Apologies, it's not wanting to go backwards. Oh, there we go. Sorry about that. So, monitoring at FFT, we had a driver in PR19 for event duration monitoring spills into the storm tank and potentially spills from the storm tank, so we know what's happening there. And then we had a driver called U14, which is to install MCERTS flow monitoring on the flow pass forward at the overflow, and to utilise existing monitors where they're available rather than going to the cost of new ones, and install new ones when needed. There was a UIM2 investigation which was to look at monitors that may be suitable and to check whether they can be converted, can be adapted to MCERTS during the AMP period, and if they could, they would be delivered in this AMP. If not, they would have to be put forward for the first year of AMP8. That would be 2026, 2025-26. And so essentially, by the end of the first year of 2026, second year of 2026, every sewage works that treats more than 50 metres cubed that has a storm overflow will be monitored for flow pass forward. So it sounded like a simple driver, but as all things, including this, it doesn't turn out to be. It's not. Yeah. So companies proposed use of existing monitors. So rather than where they had existing monitors that were not at the front end, not right behind the weir, measuring the pass-forward flow while the overflow's operating, companies thought it may be useful to explore using monitors that are at the back of the sewage works. And there was an UQA project carried out to try and find a means of assessing compliance using monitors in that position. Didn't really have a great deal of success, but we left the option open in case anyone come up with a solution. So during the process we also recommended that the UQA project recommended that EDM monitors also achieve MCERTS, and that was a tough one to convince the companies of, and with it not being funded in this AMP, so we've required that at the beginning of the next AMP. And we also had an issue about matching the frequency of data with the FFT normally being recorded in 15-minute and the spill to the storm tanks and from the storm tanks in 2-minutely. So matching up those flows to assess compliance is an issue as well. And also the companies wanted to use storm tanks in certain circumstances where they were trying to do some maintenance work. And then of course supply chain issues have cropped up as an issue also. So to permit FFT, we already had a condition which basically says the pass-forward flow is a minimum when the overflow is operating. We refer to it as a flow pass-forward rather than flow to full treatment, simply because that's wording in the permits, and it's consistent with storm overflows. MCERTS inspectors rely on a guide as to what what flow they need to monitor to be sure that the monitor is monitoring the right flow. So we have to be clear in the permit what the flow is that they're monitoring. And that led to a definition which is up now, and is essentially saying that the FFT is the flow that arrives from the upstream catchment that is then passed forward to treatment. Now that sounds patently obvious, and it is, except without that definition inspectors would be left in an ambiguous situation when it comes to return flows. So if there was a return flow which went around the monitor and therefore was double counted by the monitor, they needed to know which return flows to count and which not to count. So the definition was it's got to be from the upstream catchment to be counted. So essentially the FFT setting condition, the minimum pass-forward flow, remained unchanged, but we added an additional limit so we could measure the performance of the companies rather than it just being a straight pass-fail in terms of if there was one reading throughout the year that didn't comply with the FFT, then it's a fail, and if there's more than one, less than one, it's a pass. So we added a limit which takes account of potentially the monitoring uncertainty, the monitor in relation to where the pass-forward flow occurs, and we came up with the requirement that for 95% of the year, 92% of the readings whilst the overflow is operating must be greater than, 95% of the reading must be greater than 92% of the flow pass forward while the overflow is operating. And we had a management system objective for the companies to define how they were going to quality assure the data to ensure they only include good data. And then there was a data compliance condition which requires them to have 90% good data for both EDM and flow for 90% of the year, and also that monitors couldn't be down for more than 2 weeks in a row at any one time. So Going forward, UMON 4 meters will have MCERTS. UMON 3, that's the EDMs, will have MCERTS. The guidance for that is yet to be finalised. There's a published EDM MCERTS product manual and an installation manuals needed, and we need to put it into our guidance. There's still a lot of flow guidance to be published, unfortunately. In terms of certification, it will be a separate certificate for measuring flow passed forward at a sewage works compared to the total daily volume on the final effluent. That's so we can keep one separate, especially where the same monitor is being used for both purposes. It may pass for one or it may fail for the other. The different requirements are for the total daily volume measurement, it has to be plus or minus 8% in terms of the volume, whereas for the FFT measurement it's plus or minus 8% in terms of the flow pass forward rate at the FFT. So it's two different requirements even where it's the same monitor. So return flows were a major issue. We found that the inlets at sewage works were far more complex than anybody had foreseen, or any of us had foreseen, including the companies, where there were return liquors going back into the sewer upstream of storm overflows, which is clearly a non-compliant situation where they can discharge liquor over the overflow into the storm tank and off to the environment. We had to separate out permit, compliance from MCERTS monitoring, so we could get the MCERTS monitoring in. So we've allowed return liquors to be monitored and subtracted, even though they're in a non-compliant situation, and we'll deal with the compliance separately. Then there was other potential flows apart from liquor returns. There was site drainage, which was getting into the inlet upstream of the storm overflow. There was storm tank returns and imported effluents, and we had to work out how to deal with those. And the main method with those is we've accepted site drainage as being part of the catchment flows. The storm tank returns generally shouldn't be happening when the spill to the storm tank's occurring, so they didn't need monitoring and considering. And the imported effluents again shouldn't be being discharged upstream of a weir at a time that the overflow is operating, so we need management systems in place to prevent that. Where companies want to use monitors that are not in the ideal position, just downstream of the storm overflow, it's their responsibility then to try and ensure that the monitors are reflecting a flow that is the flow that's come from the flow pass forward, and it's not been altered by pumps, siphons, filling and emptying of tanks or anything like that. So that element of the variability in the flow that might occur at a monitoring site, if it's not an ideal situation, is for the companies to deal with. So UM2 investigations, these have proved problematic as well. We need to prioritise use of influent meters where they exist and they can be converted, unless they need extensive civils work. So clearly there's a grey area there that we've had to negotiate. And where they're suitable, they must be MCERTed in this AMP and therefore up and monitoring before the end of 2025. Where there's no suitable monitoring, then they can consider monitors that are not in an ideal position. Again, if they can be made suitable, they should be in this AMP without additional major works. Where there's no existing monitor, then it will be year 1 to 2 of PR 24 of next AMP, so that'll be 2025-26. So for assessing flow to full treatment, we use both the data from the FFT flow pass forward and from the EDM, and also the data quality conditions. And that annual report that the companies have to submit will inform the future EPA, which gets very good sort of press coverage, so it will give them additional incentive to perform. How it's represented is yet to be confirmed. Skip that. Running out of time. Yeah, and just to say, in order to overcome that ambiguity between 2-minutely and 15-minutely data, we allow the first flow reading not to be included as part of the compliance when the overflow starts. Because of the lag through the system, if it's a monitor that's not at the ideal position, if it's post-process somewhere, then we will require them to we will allow them to have first two readings excluded from the analysis, and we'll have to check after that we've got enough good readings that we can fairly assess compliance for those sites. So that's covered that. And then there's always a query, well, what if an overflow occurs in short bursts? If it's if it's say got a pump that's delivering a pulsed flow past an overflow and it's spilling frequently, we're only measuring flow at 15 minutes intervals and spills at 2 minutes. We'd be recording spills where the flow wouldn't be necessarily compliant with its FFT. In order to be able to assess that properly, when we're excluding the first flow reading, we've said in AMP7, so in 2025 onwards, the monitoring frequency at measuring the flow will be increased to 2 minutes also at all sites where it's possible. So, summing up, the regulatory focus on effluent load by improving dry weather flow is a good move. It takes away the sole focus on effluent quality, which could be result in flow being compromised. We're addressing, hopefully, the increased challenge that's coming from the public. The companies will be making all this data freely available for anyone to analyse and to look at. We ourselves will be obtaining the data, and we're not just looking at the straight compliance statistic. We will be looking at what's happening in those 5% of the period potentially where they appear not to be compliant, and we will be looking at potential dry weather spills which are occurring even though they are compliant with their FFT. So we'll be looking at rainfall in conjunction with that data. And companies need to plan ahead now to avoid dry weather flow fails. Once it becomes an EPA, it will become extremely sensitive for them, and will highlight any issues, as I say, with the FFT and spills. So for AMP8, the bit I think Oliver wanted me to mention, as I say, we've got 2-minutely data on flow to full treatment. We have, we have flow to full treatment, 2-minutely data. All the flow, the spill to the storm tank monitors that we're putting in this AMP will need to become MCERTS in the first year of the next AMP. And then, hot off the press, we've just had approval for 6,000 further emergency overflow EDMs to have MCERTS and to be installed in the coming AMPs. And that will be at the back end of the AMP, and this is a big shout out really to the MCERTS inspection fraternity, that we've ended up with a situation where there's a huge hump in MCERTS requirements towards the end of this AMP and the first year of the next AMP, and on its own that might pose problems for MCERTS inspection companies. We're hoping they can gear up, recruit more inspectors in order to, and this 6,000 monitors that's coming in for the final 3 years of the next AMP would hopefully give them the confidence that there's plenty of work to be going forward. That we'll be able to flatten the hump by having perhaps two years. I can see some of this. 2 years heavy load in 2025, 2026, and then follow that on with the 6,000 monitors in the following 3 years. I'll finish there because my time's gone. Thank you. Thanks, Oliver.
Regulatory bit. So I get with mic range so everyone can hear me. Now, I got landed with this at the last minute. Somebody rang me up on Friday and said, Oliver? I went, yeah. Can you possibly do my presentation on Tuesday? So this is a bit of a mixed presentation, and it's quite ironic because I don't actually work for a water company anymore. But we've just heard Rob talking about it from the regulatory point of view. We're going to hear me talking about it from the water company point of view, and then John Curtis, who's standing at the back. Hello, John. Yeah, that's you. Yeah, he's going to talk about it from constructability and the construction point of view. Next AMP, yes, there's flow. Yes, there's. Everyone heard of Section 82? No, Section 82 is the upstream and downstream of all storm overflows that's hit the Environment Act. We're going to be talking about that tomorrow, and you're looking at around 15,000 installs. We've just seen Rob talk about 8,000 installs of level monitors on emergency. 6,000 was it? 6,000 installs on emergency overflows, and we've got more UMON 4 FFT monitoring. So the UM2 program, Rob actually mentioned it. Yeah, I think it's fair to say it probably didn't go to plan. And depending on how much it's going to cost, I'm going to put Rob on the spot. Maybe worth looking at again, second bite of the cherry, depending upon what it's all going to cost in the next AMP. And situations do change within flow. I can't actually see. God, no, I really can't see that down there. So I'm going to have to look back, and I'm going to start needing glasses. The programme was to assess whether we could use a final effluent flow meter to measure FFT. And it has been done. It has been done this AMP. We're just about to get the first few through certification. And some of the savings we're talking about £800,000–900,000 per site. So it's worth going at. And it's quite good. We did develop a process uncertainty. I think the sticking point with the UM2 program was nobody could quite work out process uncertainty. If you want the calculation, there it is. And that's been given to the water companies. And it's looking at the delay through the treatment works and depending upon the complexity of the works. It is possible, but it's not easy to do. UMON 3 program, if you didn't bother doing this early within the AMP, I think we found out probably too late. If you didn't bother doing it this too early, you were stuffed with the UM2 program. This I've actually nicked from the Thames presentation, which is part way through this presentation. It's quite a neat install on the side of a channel. But I think with UMON 3, there's been a very variable amount of installation. Some great installations like this. Some not so great. That's a capacitance probe on a weir. That green and yellow labelling says UMON 3 and UM2. UMON 3 and EDM2. And when I went up to that capacitance probe, I could move it about 90 degrees and tap it against the side of the weir. So when an MCERTS inspector goes to that, they're just going to go, they're going to laugh maniacally and walk away. And quite rightly so. This was actually really important to do properly, especially for UM2, because you know when you went to storm, yeah, Mark, don't stare too much, don't take the mickey on us. But yeah, this is looking at installation, not looking at a fag packet way of doing it and doing it properly first time. We all know it, we all talk about it, why don't we do it? At the end of the day, it's going to get inspected, that's going to fail. remember, this is all regulatory data that's being reported to the public eventually from 2026. The UMON 4 program, we got a lovely present halfway through. And when you're designing, I'll go to this. Everyone's seen this curve. It's a very standard curve. The earlier you get something within the design process, the less it takes to change it. So when we got this nice little table halfway through, I think it was about a year ago, rightly talking about wash water flow monitoring, talking about returns being in the right place, and a variety of rules. It was a bit of a surprise, and at the end of the day, we all thought wash water, it's minuscule, we don't have to worry about it, and it just added another layer of complexity to everything that was doing. John will probably tell you later that another layer of complexity puts a lot of headaches, a lot of redesign work, and a lot more cost. Interestingly, we had a flow meeting yesterday, and not all of the water companies were still that clear about what counted and what didn't. There were questions going, well, if I'm a contractor and I have to install this, and it turns out I didn't have to install it, that can be a disallowed cost on a contract, which for a contractor is a lot of cash, a lot of wasted cash. And so having absolute clarity as early as possible, I think would be a key learning point moving forward. And when we move away from flow monitoring, admittedly, but say Section 82, which is a multi-billion £1 programme of works, then we need that clarity right up front as soon as possible, because any change there isn't going to cost £1 million, 10 million, 100 million. It's going to cost 500 million, 800 million, billion pounds. And that's where things start to get complicated. So as I said, the sooner we know things, the sooner we can set the rules, at the end of the day, the less changes we're going to have to make, and programs can ramp up. We're talking, okay, simple things in UMON 6, level monitors, but we were talking those simple things in EDM2, last AMP, and that was installed. So in some ways, we've got to get the right thing in the right place in the right way. The least ambiguity, the better. When we get to AMP8, I think we've got, I don't know exactly the number, I've not quite seen the exact number, but we've got to be talking 300 or 400 installations. These aren't simple mag meter installations, simple time of flight meter, simple flumes. These are the ones that no one really wanted to do. Admittedly, this is on the final effluent works, and it's a works I did 10 years ago. It's a 700mm mag, concrete pipe with asbestos in it. It ended up taking us 8 months to build. And I think the original plan, and it's probably changed, Rob can either nod at me or wave at me and say, but was to install all of the AMP8 flow meters in the first year. Well, if their job's like that, not a chance in hell. But in some ways, we've got to, because next AMP we've got UMON 4, we've got Section 82, we've got UMON 6, and it's going to draw the entire installation skill in the whole of the UK. That is what we are looking at the minute. Every single instrumentation installation company in the UK is going to have to be working on Flow, Section 82 or UMON 6. There's going to be no more work. We do not have the instrument technicians. I've just come from the Learning and Development Theatre. Now, learning and development is really important in this country. It was empty. We are lacking skills in this country, especially around instrumentation. We kicked off the instrumentation apprentice competition earlier. Great to see, because we're going to need something around 1,400 instrument technicians in the next 10 years to do this sort of work, to do the maintenance work, to do everything. We just do not have that capacity in the UK, even if we took every single instrument tech in the whole of the UK. So this is where it switches over to the Thames. The person from Thames kindly gave me the slides. I haven't fully reviewed them, so I am going to be slightly reading from them. But this is what has been done in Thames. This is what the Thames Challenge was. So 121 UM2 investigations in year 2, 238 UM3 installations, 118 UM4 pass forward flow, and forget UM5, it's new treatment works. Well, small treatment works that come under the MCERTS driver. So 400, almost 500 outputs, and some of that's planned in the future, because we're only, where are we right now? I think we're starting, April will be year 3. So year 1, 2 is what they've actually done. That was the original WINET program. There's still a hell of a lot of work to do. But in what they've done, they've come across, here are some of the challenges that they faced. COVID. The industry basically stopped in COVID. Still managed to do their program. Lack of ops understanding. Here comes skill. Here comes we always knew with UMON 3 and UMON 4 there was going to be a cultural change within the water industry, within operations. Every single spill to storm was going to get measured. And there's still that operational mindset that it's going to take a little bit of time to catch up. Access to sites, the business systems. We're moving to 2-minute data. I don't know if anyone's done the calculations, but at 2-minute data, every single instrument is going to be recording 250,000 pieces of data every year. The challenge of managing that data and managing that data quality within the water company is insane, absolutely insane. It's going to be huge undertakings. You've got 2 instruments per site, which means you've got 500,000 pieces of data for every site in the industry as a minimum. Some sites will have 2, 3, 4 5 flow meters. I think I went down to one in Thames, which would have to have 6 flow meters. So that's 3.5 million pieces of data just to measure flow. Sounds a lot, doesn't it? It is. If you multiply that across the water industry, there are roughly 3,500 sites. So what's that? 175 million pieces of data a year. The water companies are going to need new servers just for flow measurement, let alone the data transmission for that. Massive, massive undertaking. One of the challenges we found this AMP is the lack of MCERTS inspectors. The poor MCERTS inspectors out there have been running around like lunatics and doing inspections as fast as they possibly can. But we need more talent. We need more people. Chris Corris, I know, is sitting back there. I know Chris and his team have been running around doing as much as they can, but we need more. UMON 6 with EDMs within the wastewater network going to MCERTS. I think there's 17,000 overflows, Rob? Roughly, more or less. That's 17,000 inspections. There are what? Chris, shout out for me. Is there about 10, 12 MCERTS inspectors? Something like 10, 12 MCERTS inspectors. So 17,000 plus 3,500 TDV plus something like 2,000 FFT plus 2,000 UMON 3s plus 6,000 UMON 6s. Is anyone keeping track? Because I'm not. It's going to be 3,000 or 4,000 MCERTS inspections a year. We just do not have that capacity in this country at the minute. And the skills shortage is going to be the biggest barrier in instrumentation moving forward. But there are technical challenges, and a lot of these have come up if I was going to be very critical, some of the standards just aren't out there. The Good Practice Guide for EDM, EDM2, funnily enough, the newest version doesn't have an accuracy requirement written into it. That's a major problem. The UMON 3 guidelines are coming out anytime soon, plus or minus 5 mil. Technically, that's really, really difficult. I think there's only 1 or 2 instruments on the market that can cope with that. But the supply chain are doing great things. I've had a word with one of the companies this morning and went, "Oi, your accuracy's at 10 mil at the minute. You've always told us you can do better. Can you please put that in?" And they've gone, "Oh yeah, we never thought of that. And that enables us." A lot of what any of the MCERTS people in the room will tell you is MCERTS is all about having the different technologies that you can potentially use on a different application. Every site's unique in a different way, and we've got to look at that technology and use it what's best to use. The more choice that we've got out there, the more technology we can potentially use. I remember years and years ago, Colchester, a 1 metre party mag. It was £36,000 to buy that instrument. It had to be hand built in Germany, and it cost 99 grand to install it. 2 years later, could have shot myself in the foot. The right technology came out, but to do that application would have cost 14 grand instead of 135,000. So yeah, the technology does develop. And this is what Thames have done. They've looked at the technology, they've come out, they've looked outside their normal channels, and they've innovated. So you can see some of the innovations here. A rather neat looking UMON 3 installation. I always go, my God, you should double brace any level monitor. In fact, this one is so small you don't have to. There's no weight on that to drag that down. It's not even big enough to do what operations usually do, which is put their foot on it. It's not even big enough for a foothold. So quite a neat solution. And some of it is using current technologies in an innovative way like this. And this is a temporary dashboard. I talked about 250,000 pieces of data. That's what that looks like. It looks a mess when you look at it, but yes, we're going to have to look at these innovative ways of doing this, of looking at the data and understanding that data. The choice is we either do it in an automated fashion, or we have about 100 staff in a room tapping away at all the data, which just isn't possible. So yes, we can see what Thames have done here. A nice, neat dashboard allows them to look at it. This is, if you go over to the digital theatre over the other side, if and when you've got time, don't leave here now. If you go over to the digital theatre on the other side, this is the sort of things they can look at. How can we visualise the data better? How can we give the right data to the agency and able to measure compliance? And that's a problem, and it's a large cost. This can be, some companies, they'll be spending 2 or 3 million quid on this. And that's what these sort of things cost. I don't know what, I'm making it up, I don't know what Thames actually spent on this, but, and I believe this is a temporary solution until they get it into their sort of centralised databases. But yes, they've looked at innovative ways. We've always been challenged about mag meter cleans within the agency. You can actually see that's quite an innovative way. Just need to change that plate around and very quickly clean that flow meter. You wouldn't quite want to do it live, but it's quite a nice, neat installation, as long as you can make sure it's pipe full. And I imagine that's on a pump main, and that's why they've done it in that way. I've not got, but it does take quite a lot of civil construction, which gets me back to that point. Year 1 of AMP8, I'm guessing we've got something like 400, 500, 600 installations to do. It's not going to happen. When you have to build things like this, that takes time. And it's not just as simple as installing a bit of kit, especially for UMON 4, where we may have to rip down the front end of a treatment works, and we've known about that for a while. But Rob covered the next bit. what are the challenges, 2-minute monitoring and the implications. So one of the things that I know has been mentioned within the industry is pen stocks. Yeah, I'm looking at you, Mike. And here's a pen stock from a wastewater treatment site. Pen stock in the background weighs about 9 tons. You're not going to move that very quickly. So that pen stock probably moves about 20 seconds every minute. Sorry, 20 mils every minute. No more than that. If you do, the whole pen stock will start dropping into the water, and it gets very, very messy. But also the recording, can we control the whole system that fast? Yes, we could potentially raise up the FFT so it's always above, the flow is always above that FFT, but there's a cost implication of that. And that cost implication, or certainly on large sites like this, is enormous. It can be millions upon millions upon millions of pounds. There's going to be challenges with control equipment. There's going to be a step change challenge on data management. I remember with the smart water metering that's being put into Thames, their biggest challenge of putting hourly metering on customers was data. They had to stop at one point, and they had to set up a whole separate IT system within the company just for the data. Are we going to have to do that with this? More than likely, yes. And so there's going to be costs that may not have been thought about within the program around data management. And moving to 2 minutes just makes that 7.5 times worse. So yes, there's been some great work done so far. There's a huge amount of challenges to come. And it's going to be an interesting few years. Questions? Have I blown everyone away to silence? Sorry, the cameraman at the back was just pointing his gun at me. Nothing. In that case, I will bring Mr. Curtis, who used to do some sterling work for me when I was at Anglian Water. He's going to talk about some of the challenges on the ground, some of the Come on, stay. Come on. John is a really good speaker. Yeah.
Good morning, everyone. Welcome to WWEM 2022. My name's John Curtis. I'm a project delivery manager with Morrison Water Services, and Oliver kindly asked me to come and talk today about the perspective we have as an installer. So just to give a little bit of background, I work for Morrison Water Services, and we work in the Integrated Operational Solutions Alliance within Anglian Water. That is made up of Anglian Water, Morrison Water Services, Barhale and Kier as equal partners. We operate on a pain gain commercial model with a focus on driving efficiency through receiving a target cost for the work that we do. And in delivering those projects, we take on some of the client's responsibilities by providing a solution to a need rather than the traditional kind of client-contractor relationship where we would just be quoting on a work that the client already accepts that would fulfill that need. What that does is that gives me and my team a good perspective of kind of what it's like for both sides of the fence, really, especially with delivering UMON4, where the need is to provide an M-certified FFT flow monitor. I started working in the water industry in 2007 with a contractor to Anglian Water. And my introduction to MCERTS started a couple of years after that. I then progressed over to Morrison at the beginning of AMP6 when iOS started. And so my current role is project delivery manager, where I work with a team of project engineers delivering primarily TSFR MCERTS and UMON4 schemes across Essex and the south of Suffolk area in Anglian Water. So as I've heard on previous conversations, what Oliver alluded to, really, we share a lot of the issues that is across the the business or the whole industry really. And one of those is resource and knowledge. So for me, having the appropriate resource in the team with the knowledge that they need to deliver the work is key to any kind of work or project, and UMON's no different to that. With the expansion of MCERTS to apply not just to TSFR but now to also UMON, it requires a huge investment in people with a great deal of learning, not just for those like myself who have already kind of fairly well versed on TSFR MCERTS, but to get a full understanding of UMON, and also people new into the industry, because there aren't the resource there in the industry. And my team have had to grow by bringing people in to the industry with no former experience. We operate also in iOS direct labour model, so we have our own civil, mechanical and electrical teams to actually do the work. That upskilling as well is key in making sure that we deliver what is needed on site and to the appropriate standard. We're all only as good as the teams we have, and it's natural that if MCERTS is going to grow and grow and grow, which it is what is going to happen, our teams need to grow with it. The hard bit is achieving it. The second kind of common issue, I guess, that we've got as well as installers is the MCERT standards. Not having a clearly defined, ready, available and concise standard to refer to does provide significant challenge for me and my team, particularly around return flows. There's a lot of guidance, there's a lot of opinion as well and information out there, but it's not pulled together in one area, and because of that it's just open to misinterpretation and or risk of being missed completely. With the type of contract that I work on, and Oliver alluded to it earlier, that if we actually do work out that is potentially seen as not required as part of the scope at a later date even, that's a potential disallowed cost for us. So that actually puts my organisation at risk by potentially a scattergun approach of let's just install loads of flow meters that could be deemed as actually insignificant or not required at a later date, which makes our job quite a lot harder really. Of course, some sites don't need any clarification, and providing a solution with a return flow is as straightforward as moving a pipe from upstream to downstream of a flow measure or the primary flow meter. That in itself comes with risks, in that you might have a perfectly functioning flume, but by then putting a returns pipe down there, you could potentially drown that out. So there's still considerations that need to be taken into account, even on what sounds like a really, really simple task. We've identified a number of sites where return flows are then blended with flows from the incoming network that are then pumped to a balance tank, and how they're exactly going to be split out and accounted for, and that is something that, for me, the biggest efficiencies we've had is having time to fully consider what we need to do. But ultimately we need to know where the goalposts are, to be able to do gain what is necessary and not do what is not necessary. There's a great deal what we can take from existing TSFR MCERT standards that, like I say, we could pretty know that they are going to be applied to any future standards. Things like using an M-certified product, being able to perform some sort of secondary verification on that, and also the ongoing maintenance of it and enabling that to happen. But then when it comes to the actual installation that we do on site, what we've found as well is that the majority of sites were never ever designed with any consideration or very little consideration for measuring the flows coming into site after storm separation. So the area on some sites where, especially this one as an example, where you've got a combined inlet works that has the storm storage, the storm overflow, primary settlement, all in the same structure, doesn't give us much room at all to try and install a suitable MCERT product. What we do look to, though, is to try and be as light a touch as possible on site. Compliance is always key to us, and to be the least intrusive we can. So looking at ways of installing flow meters that are non-contact, that don't interfere with flows if we can, is always for us one way of being at least impact on site as we possibly can, really. And what that also does is, from a commercial sense, is that it means that we don't actually have to manage the flows. Managing the flows is one of the biggest issues that we have to deal with and we face on installation. So what we look for really is to try and keep that down to a minimum, try and keep that cost down to a minimum as well to be commercially viable. So this is particularly kind of important when we have to look to installing a new flume. So what we've looked to do and try and use the traditional kind of over-pumping techniques as almost like a last resort, really. And so what we've found on some sites is that if we can look to manage the flows by actually bypassing them, so in the typical bypass pipe that you would have for a mag flow install, to be able to do that with an inlet flume, it just means that we reduce the management costs of over-pumping. We're also reducing, fuel costs, and admittedly the installation of the bypass pipework comes at a cost, but what we've found is that not only is there a cost saving in doing that, not on every site, but on a lot of sites, it also is less impact to the site. What it also does do is, when we look at site control, is that we might be taking an existing inlet flow meter offline. It's very hard to establish, and unfortunately, existing control drawings, existing parameter settings and that aren't readily available. And even though we've interrogated the instruments, we've found that there aren't any relays that are used for control, but that doesn't mean that the 4 to 20 milliamp analog signal isn't used elsewhere on site for chemical dosing and such like. So what we do, if we think there's a risk of that, is that, and you can just see on each side there, this is the same installation, just an upstream and downstream picture, would be to install a mag there, which would be connected into the existing 4 to 20 milliamp signal to not only provide resilience to site, but it also gives us an indication of that we are still passing at least the FFT value to site, and that can also be managed as well with a check valve if we need to. On this particular one, we didn't need to install a check valve, but that is a consideration that we'll go to. Each site is different, and so on some sites as well, we would also install a maintenance point so that pipe work and the flow meter sensor could be cleaned on a daily basis. That is the same site after we've done the reinstatement and kind of finished the work. So another option we can look at is constructing adjacent to an existing flume or pipe. Again, it's to keep that management of flows down to a minimum amount of time. So here it would just be we would need to manage the flows whilst we're then connecting the new flume into position. Yeah, it's so similar to what we do for TSFR anyway, and we've learned a lot through the years on that, and it's just adopting it to inlet works with which has its own, we're dealing with raw sewage rather than final effluent typically, which on the cleaning side and that requires a little bit more attention, but in general the principles are the same. And that was the same site after we've reinstated. So mostly have spoken about the primary devices, but the selection of secondary device as well is also key and can provide, this is maintainability is what I just missed out. So with regards to MCERTS, in that we're taking a basic process flow meter that has either had very little or no maintenance done on the past, and to get an MCERTS accreditation where it requires it to be maintained, and on a CDM element as well, we've got to look at how that can be done and how that can be done safely. A great number of inlet flumes I have literally just got covers over the top. They're used as walkways, so it's just then adapting that to either open the area up and so that maintenance can be done easily and safely where you've got an existing walkway, or in the case of where you've got the walkway is needed for regular access, then we look to install hinge covers that are lockable, which maintain the minimum asset standards with angling water, to allow that maintenance to be taken place. It's just another consideration of how site can achieve MCERTS, and ultimately if you make something easy to maintain, there's more chance that it's going to be maintained. The other thing is, let's say, the secondary device, so the actual instrument itself and the selection of that can be key in how we can reduce costs and also maintain MCERTS really. So apart from actually using the MCERTS device, we look at using instruments that can provide a more cost-effective solution, and advances in the instrument manufacturers provide instruments that would enable both UMON 3 and UMON 4 compliance. And this is just one example on a number of sites that we've already adopted that to be used then in the future on UMON 3. So by using the instrument that will do both just on UMON 4 at the moment, will only require a small investment for UMON 3 in the future. But currently what we're looking to plan on alternative construction techniques, so things like off-site construction, again to just minimise the amount of site time, and use of composite materials as opposed to the more traditional. And I think these methods will continue to grow and become more widely available and cost-effective options. So kind of going forward, really, the challenge is to attract not just people into the industry, but the right people with the right attention to detail, and to continue to look at new technologies, which is, one of the good things about conferences like WWEM is that it gives us that platform to see suppliers in one place for them to, put on show their latest advances and products in technology, and also to confer and share ideas with each other. Thanks for listening.
Thank you.